Hello everyone, myself Bhavani, Assistant Professor in IT Department in SMIT. We are going to see about and then remote user authentication principles. Nothing but user and systems are located at different sites. Communication occurs over insecure networks. Authentication data must be protected. Replay attacks must be prevented. Passwords alone are not sufficient. Encryption ensures secure identity verification. Timestamp or nonces improves security. Trusted servers are often involved. These are the principles used in remote user authentication principle. Let us elaborate. Nothing but process of verifying the identity of user who access the system or network over an insecure communication channel. That's most important. If there is insecurity in communication channel, we need to identify who user and who is going to access the system. See, let us define what it is. A remote user is legitimate. Credentials are not exposed during transmission. Communication is protected from attackers. Actually, what we need for this remote user authentication is we need open and insecure network. That's most important. And then risk of impersonation, and then possibility of eavesdropping and replay attacks. Protection of sensitive resources. Okay. And then principle will be first principle, we should identity verification. Second, confidentiality of credential is most important. And then third, protection against replay attacks. Fourth will be mutual authentication. Fifth will be resistance to man in the middle attack. Sixth will be use of session keys. Seventh principle will be scalability and efficiency. Eighth will be trusted third party. These are the principles. Okay, now moving on to remote authentication using symmetric encryption. Nothing but shared secret keys are used for authentication. Challenge response protocol verify identity. Password are not sent in plain text. Why? Because password is most confidential. We need to send the password in ciphertext, okay, not in plain text. Noses prevent replay attacks. Requires secure initial key distribution. Efficient and fast compared to public key methods. Scalability is limited in large networks, often used with trusted third parties. Moving on to Kerberos system, okay? It's nothing but trusted third party authentication system developed at MIT for distributed environments, uses symmetric key cryptography, eliminates sending password over the network, relies on a key distribution center, provides mutual authentication, uses timestamp tickets for access, widely used in enterprise network. Okay, this is the Kerberos system intro. Let us speak about what is Kerberos system. Actually, it is a ticket-based authentication protocol, originally developed to authenticate user in distributed system. Okay, the objective for this system will be it is secure remote user authentication, prevents password disclosure, and then it provides the mutual authentication, protect against replay and impersonation attack. It enables single sign-on. Actually, it has some components. Okay, there are three main components. First one is client, which is the user. Second one is server, which is service server. Third one is key distribution center. Client actually requests access to network service. Server provides network resources like resources in the sense file server, mail server. Key distribution center, it has the trusted third party key consists of authentication server, ticket granting server. Okay, moving on to how Kerberos is working. There are a few steps how Kerberos is working. Mainly, we are going to see about the 5 steps. Okay, step 1, authentication request. User send login request to authentication server. And then step 2, ticket granting ticket. Nothing but as verifies the user, like authentication request verifies the user, and then ticket granting ticket. Then moving on to session keys. Service ticket request, nothing but client sends TGT to ticket granting services, okay, requesting a service regarding the Kerberos system. And then service ticket issued, it verifies TGT and then issues a service ticket and session key. Service access, client prevents services ticket to the server, and then it verifies the ticket and then gives the granting access, okay. Password is never sent over the network. Mutual authentication is achieved. Kerberos ticket, nothing but TGT, ticket granting tickets, okay. It's allow user to request server tickets without re-entering password. And then service ticket, that is used to access a specific network service, okay. And then it will be providing some security features for the Kerberos system. It's user symmetric encryption, timestamp tickets prevent replay attacks, mutual authentication, session key protect communication, okay. By using Kerberos system, we have the advantage of stronger security, single sign-on support, centralized authentication, widely used in enterprise methods. This is the Kerberos architecture. Key distribution center consists of 2 servers. And then authentication server verifies user identity. Ticket granting server issues service ticket. User authenticate once using a password. Ticket are used to access multiple services. Time synchronized is request. Session keys ensure secure communication. Improve security and user convenience. Moving on to Kerberos authentication process. User need to request authentication from the AS. AS verify users and issue a ticket granting ticket. Prevents TGT to the TGS. TGS issues a service ticket. Prevent ticket to the service server. Mutual authentication is achieved. Session key secure the communication. Password never travels over the network. Then remote authentication using asymmetric encryption. Public key cryptography used for authentication. No shared secret key is required initially. Digital signatures verifies user identity. Public key are distributed via certificate. None just prevent replay attacks. More scalable than symmetric system. Computationally more expensive. Used in SSL and TLS secure login. Comparison of authentication techniques. Nothing but symmetric methods are fast but less scalable. Asymmetric methods simplify key distribution. Kerberos provides centralized authentication. PKI enabled global trust relationship. Certificate management adds overhead. Each method has unique advantages. Selection depends on system requirements. Hybrid approaches are commonly used. Let us end the session. Okay. See, first we have been discussed about the key management. It's vital for cryptographic security. Second, we've spoken about the secure key distribution prevents unauthorized access. Third, we have been discussed about certificate. X.509 and PKI support public key trust. And then authentication. It verifies user identity. And then we have been discussed about symmetric and asymmetric methods are being used. And then moving on to Kerberos method, which offers efficient centralized authentication. Remote authentication is essential in networks. And then proper implementation ensures secure system. Thank you.